Yeah, good morning. So we were on our 21st lecture of our course MEE6025 Vehicle Crashworthiness. And this we are going to have this lecture today, this one and one more lecture this afternoon, so that we would be able to complete module 4. So currently we are in module 4. We were started that in last lecture. The module 4 is titled as Pedestrian Safety and Ergonomics. So in the last class, we were essentially going through in Indian scenario, our own traffic signals and what are the guidelines that pedestrian can be safe on road other than vehicle occupants. And we had a elaborative informative lecture in the last class on pedestrian safety, road user safety. Other than those are present in the vehicle. Of course, we have looked at the important traffic guideline signals that we are supposed to follow is not only for road user, also for road user as pedestrian, also for drivers occupant in the vehicle. So Jharkhand police website that we have looked at, and we were able to educate ourselves what all the tips that we should follow and what are the various reasons that these accidents can happen, and how important we are learning systematically to get our driving license, and and so on. So many things that we were looking at in the last class. And today's class, we are going to essentially look at in 2 periods, vehicle ergonomic design. So let me have this lecture to start to share my PPT. Okay. So hope you are all able to see the slide. This is what was the last lecture we ended with. Please go through this website of Ministry of Road Transport and Highways for further information on road safety, especially for the pedestrian safety. And there are traffic rules magazine that is published. You would be able to download that from Jharkhand Police website. So you may go through that. That is in Hindi version. So you may go through and then get to know more of traffic rules. And today's lecture, again, we are going to continue with the pedestrian safety and ergonomics, and more on ergonomics side. That's what we will see now. So as I have stated in the last class, lecture points for this module starts from pedestrian safety, and we will end the lecture by studying crash dummies. So in this, we were essentially talked more on the first point in the last period of pedestrian safety, and importance of ergonomics in automotive safety is what today we will see, and location of controls, what is anthropometry and human impact tolerance, and so on. And this determination of injury threshold, severity index, and study of comparative tolerances and crash dummies, again we are going to look at in detail in the upcoming modules. That is next module we will have titled vehicle safety systems, where we are going to look at in detail what are the safety systems available in your vehicle, that is classified broadly into passive and active safety systems. Those systems working principles and so on we will do in a separate module 5 on vehicle safety systems. And then we have 2 more modules in our course. One is injury mechanisms and severity. So we will see at that time these points in detail, and also a dedicated module on crash dummies, introduction to the dummies that are used in vehicle crash testing. So these are all something that are left in our syllabus as to complete this course. And now we are in module 4, and today's lecture is more on focusing on ergonomics in automotive safety. And I will spend 2 periods for that, this period, and then one more period starting at 2 o'clock today. So with that briefing, let's proceed looking at What is ergonomics? So if you look at the dictionaries, it defines ergonomics as a scientific discipline that uses principle of biotechnology and engineering to make products more comfortable for workers and consumers. But ergonomics is not just about design, it's also factors in how we use things. So when you say ergonomics confined to automotive design, how packaging of occupant go inside the available space of your vehicle with an anthropometry study of human. Anthropometry means the dimension of human. So how this dimension of human is referred inside the vehicle with reference to the vehicle coordinate system, so that the occupant can have comfortably able to use the systems in the vehicle, like steering system, or it is accelerator, clutch, or brake system, or your seating position. So there are many aspects that go in ergonomics of automotive design. So you can see that this itself is a course offered in many of the universities. We are going to confine our aspects of ergonomics to automotive design. So it is not only that, it can be for any environment where human and machines are involved, is what is called ergonomic study. So there are 5 aspects of ergonomics as far as automotive is concerned. One is ergonomics for safety, comfort, ease of use, productivity and performance, and aesthetics. When you say aesthetics, it is not only to the exterior of your vehicle is concerned, also aesthetic aspects of interior of the vehicle concerned. So these are the main 5 aspects that go into vehicle ergonomics. So vehicle ergonomics, prolonged periods of sitting can place heavy demands on our posture, particularly when sitting in a vehicle due to added effects of movement and vibration on the body. See, when we are sitting in a vehicle, in a stationary vehicle, is different than when you drive the vehicle. So when you drive the vehicle, you have to be with a comfortable posture. Additionally, that has to get suited to the movement of your vehicle, and there are vibration coming inside the vehicle and so on. So anything that you are doing the operation for a prolonged period, the sitting posture is important. See, I sit for longer duration, early morning till time for your lectures. I get neck stiffening effect also. I should not sit for 3-4 hours continuously. You cannot sit for morning till evening for listening to the lectures. So if at all sitting continuously it happens, then you have to have some periodic measures that you are giving some in between breaks. You walk and then come back and sit, or you are seated on a seat, how comfortable that sitting under and so on, that you are to be very careful. Similarly, in a vehicle, a prolonged drive require a comfortable posture. So the vehicle seat design go into kind of rigorous ergonomic design. We will be doing that, looking at that all rigorously, those all aspects in the next lecture. I'm going to brief this particular period overview of vehicle ergonomics. So being comfortable and well positioned in a vehicle aims to reduce driver fatigue and the development of musculoskeletal disorders. So the important effects that would be if it is not properly designed ergonomically, then driver fatigue is unavoidable, as well as this musculoskeletal disorders are also going to happen. So to avoid that, we require appropriate ergonomic design. It is imperative that everyone using a vehicle for work absorbs adequate ergonomic requirement to minimize the risk of injury. So the ergonomic design is not appropriate. There is also a high risk of injury that would happen during operation of your vehicle. So some of an important aspects that go in consideration in vehicle ergonomics is seat height. The seater, the occupant, as well as the driver and other passengers sitting inside the vehicle. The seat height is important. So raise the seat to ensure the driver has maximum vision of road. That's very important, because we have looked at in vehicle dynamics. The vehicle dynamics, how do you look at it? Is environment, driver, ground system, vehicle, all put together is one system, closed loop system. So appropriate vision to capture environmental condition is not happening to the driver. It is not easy to drive the vehicle. So the vision of the road is very important. So the seat height should be adjustable, or that should be such that complete road vision is clear to the driver. Ensure there is adequate clearance from the roof. So you cannot, your driver should not raise his head to see what is happening in front, get the road closer to the vehicle vision. And there should be a clearance from head to the roof. That's important. So seat height is something in one of the aspect. And then lower limb position. So knee should be bent in order to comfortably operate accelerator, clutch, and brake. The steering wheel should not come into contact with the top of the legs. So the steering wheel should not come and to have a contact. So we will see this all very nicely in the next lecture, how these positions all are taken care. What are the important references, reference points that are going in vehicle occupant packaging as a whole. All we will see in the next period, and this period is to get an overview. And then seat pan. So what is seat pan? Seat pan is thigh supported along the length of the cushion. You're sitting on a seat, whatever the upper leg portion is on the contact of the seat is what is seat pan. Avoid pressure behind the knees. And then backrest. Backrest is another important thing to kind of we require a backrest. Adjust the backrest so that it provides continuous support along the length of the back, and shoulders slightly behind the hip. That means the seat should not be so straight or should not come like that. It should be slightly behind. Our shoulder should be slightly behind the plane that comes from our hips. So these are all some important aspect. And then lumbar support. So the lumbar support, whether adjustable or not, should provide comfort with no pressure points or gaps between the spinal and car seat. So the lumbar is something, a point that is in spinal. So between spinal and car seat, there should be sufficient comfort. That means no pressure points or gap should be there. So it should be a full contact required. So a S-shaped spine is safe shape. So let's see how do you get. There are some back support for that purpose, so that you would avoid such kind of gap in your spinal and back seat. And steering wheel. So when you look at steering wheel and its design for a vehicle ergonomics, all objects and controls should be in ease reach to prevent unnecessary reaching. That's very important. Elbows and shoulders should be in a relaxed position with the hands positioned below shoulder level. So your hands should not go above shoulder level. I should not hold my steering like that. Steering should be, my hand when I hold the steering, that should be just in front of my shoulder or slightly below the shoulder. And check for clearance of thighs and knees. Allow 2 to 4 centimeters. So your thigh should not clearance between thighs and knees. So there should be some gap. Your thigh and knee gap should be 2 to 4 centimeter. Clearance should be there. Ensure display panel is in full view and not obstructed. So display panel is in full view means you are able to see. There are electronic and visual system in today's high-end vehicles, and that has got many of active safety systems like ABS, electronic stability control, or cruise control, or lane keeping. There are many such like night vision lights and so on. So those all control panels. That all should be easily. The display panel should be viewable for the driver easily. A good test is to be put your arms straight in front. That means above the top of the steering wheel. The top of the wheel should sit at approximately wrist level. So the top of the wheel should be should sit at wrist level. So your wrist level and wheel top should be in that. That means when your hands should be slightly or just in line with your shoulder, and then the steering wheel should not come above the wrist level. Then headrest. Headrest is very important because there is something called a whiplash. Then when your vehicle is hit from rear, you see that you get your neck injuries. So the headrest is very important aspect of passive restraint system. So the neck should be in a neutral position with the headrest position centrally behind the head, right? And then mirrors. So adjust the rear view and side mirrors to ensure adequate vision of surrounding areas. That's also very important. So whenever we start our vehicle, we always look for our side mirrors are clear. If there are dust or moisture, we should wipe out. And you can see inside what is the rear view mirror. So you would be able to look around your vehicle comfortably as a driver, and the position of mirrors are also very important. And if you look at particularly for a driver seat, these are some of the important points that to be kept in mind. The seat should be right. So here, just a minute, there's some announcement on the road. There's some announcement of the road. Please pardon for that. So here, this is not set the seat, right? Seat should position the driver with unobstructed vision and within reach of all vehicle control. So that's an important aspect for a driver. The seat must accommodate the driver's size and shape. That means the driver can be of bulky or thin, lean, or the different gender or of different age group. So the seat must accommodate the driver's size and shape. The seat should be comfortable for extended period. If you have to drive for a long duration, you should have comfort. The seat should provide a safe zone for driver in a crash. So you should be having an adequate space around so that the passive restraint systems like airbag deployment in case of a crash, you are completely going to be covered with them, and then you would be isolated from the crash pulse that will enter the driver. So that is the kind of seat requirement when you look at ergonomics of seat alone. And then ergonomic aspects in automotive design, not only to take care of passive restraint system, also to accommodate your wholesome of safety aspects. That is visual aspect. There is something called eye clips. That is like ellipse eye clips. So there is a zone of the interior with reference to the seating position of driver or other occupant, and that zone, your eye level always should be there. So we will see that all detail in our next lecture. So here you see that visual aspect and airbag warning. So airbag warnings are something that whenever we have some panels of indicators in vehicle, before you start, you see they are glowing, and then they prompt that they are all working appropriately. If they glow and then it is go off, then it is working. In case something is not working, it will be giving you warning. So for example, you start your vehicle, but you get beep sound, or you see the glow of indicator that seat belt is not wore. So it gives you a kind of warning that please do wear your seat belt. If the airbag warning is glowing, it may show that the airbag deployment may not happen. There's some fault in the sensor of airbag. Some indication would be always there. So such kind of information should be visible to you. Your steering wheel and the display panel should not disturb it, the vision of the panel. So you have to be able to see them comfortably. Then comfort, usability of seat belts, collision avoidance system, traction control system, brake assist system, navigation system, vehicle interior controls, pedals, etc. Reach to advanced recreational systems, the music system. So these are also some of the other ergonomic aspects to go in automotive automobile design. So for example, if you look at this, all active safety system, electronic gadgets, all to be placed in a position so that they are reliable, they don't get damaged, they would work promptly. So that is what is to be ensured in design aspects also. And then coming to some of the injuries that commonly encountered during driving is what is this foot cramps are the most common repetitive driving injury. So we may get cramps in our legs. So that's one that cannot be avoided. That can be avoided if we have a proper ergonomic design of our seats and our posture while driving. And followed by back pain can be there, neck stiffness and side ache or eye strains, and which often lead to headaches. So these are all some common driving injuries. Our ergonomic design should take care of it. And let's understand this picture here, that is head trauma, neck, collar, bone, arm bones, spinal, hip, pelvis bones, and leg, knee bones. So these all would get receive this crash pulse in case of an accident scenario, or this all would be continuously getting vibrational responses, and even in a safe drive on the highways. So the diagram shows the pretty much any part of a body exposed to a chassis of the race car is at risk. So this is the reference to a race car from the reference. Injuries occurs because of body sustains impact beyond the gravity's level that it can sustain. The brain is particularly susceptible to injury because it is really just a soft tissue mass stored inside a very solid bone container called skull. The key to avoiding injury in the brain is to avoid instantaneous deceleration of a skull. That is when the skull strikes something hard. So there are trims inside the vehicle. So during your collision or accident, your head is striking the trim. Then that is going to impinge deceleration onto your skull. Why deceleration to your skull? Because in crash event, vehicle stops, but the occupant is not stopped. So if you are not properly restrained by seat belt, no, you cannot avoid you are hitting on steering column or steering wheel. So when you hit hard your head on that or on the side, you would definitely going to have a high level of deceleration pulse, and that's what is going to damage brain. The brain inside unfortunately keeps no moving, causing head trauma. So this is kind of mechanism that you get a brain injury. And then neck and spinal. So injuries also present as serious threat to life and career. These connectors type elements in our body are flexible and stretchable at a point and can sustain tremendous G loads before breaking. However, depending on angle of impact, they can break rather easily. In the other bone injuries, breakages are not as life-threatening or career-ending, but still are to be prevented. The bones of our arms, legs, and spinal are designed to be stressed in tension and compression along their length. In the case of impacts, they are often stressed in shear or bending mode. Therefore, snap relatively easily. So this is all something that go into different bones of our human body that injury associated. So though the injury on legs and other hip, pelvis, all arms are all not that life-threatening like a head injury. We can't be take it easily. So this kind of injuries can be controlled when vehicle is subjected to high level of forces more than G gravities, right? So that's what is that take in this slide. And then going to looking at the elaborative, what are these musculoskeletal disorders involved in vehicle driving, and how can we minimize that risk is what is there in a couple of slides to look at. So the driving a vehicle can be more detrimental than sitting or standing due to effects of movement of vibration on the body. Common risk factors associated with development of this is musculoskeletal disorders include prolonged sitting, fixed posture, inappropriate lumbar support, and then and manual handling tasks, and when getting out of the car. Then lower back, shoulder, and neck pain are commonly associated with prolonged period of driving. So just now what we have seen in previous slide, it's summarized, and this is from other reference taken. So how can you avoid it? Apply ergonomic principle. So what is the ergonomic principle that we have to see it? That's why this kind of motivating slide you can see how this is all done. What are the so detailed ergonomic design aspects that go in occupant packaging? That is what we have to learn. However, we will prepare ourselves for that, and this slide helps for us. So then during breaks, means intermediate breaks, 15 minutes every 2 hours it is required. You have to break your task, and then so you don't drive prolonged distance more than 2 hours. Inappropriate postural variation like stretches, walking around the car, and so on. Stop and then relax, then go, get down the car, and then again start your motion, and so on. So make small adjustment to driving posture every 30 to 60 minutes. Practice connect manual handling techniques when taking items in and out of the vehicle. If path or discomfort persists, consult your treating health practitioner for further advice. Sorry, if pain, see, I have to adjust my spectacle. If pain or discomfort persists, so your prolonged problem of discomfort, then it is better to consult a doctor. Then these are all comes under the category called musculoskeletal disorders, what we have looked at. And there is also another class called the fatigue of driver. We have looked at in our vertical dynamics. The design of suspension is so important that it has to isolate the vibration that entered the vehicle seat, so that the fatigue level because of RMS acceleration perceived can be within the level recommended by ISO 2631 and so on. We learned in our vehicle dynamics course. So if you look at here, fatigue is often ranked as the major factor in causing road accidents. So if you are having high vibration level in your vehicle, it's poorly designed suspensions are employed in a vehicle, you are already under fatigue and you are driving, so that would act as a main important factor to cause accidents. Fatigue occurs from insufficient sleep, that's important, insufficient sleep, and when drivers are required to sustain attention over long periods of time. So if you are not slept well and you drive and you doze, then it is very dangerous. So you are alerted and you're not slept also will induce high fatigue level. So fatigue results in impaired attention, reaction speeds, vision, memory, impacting our driving ability. So fatigue could degrade this all activity. Fatigue can result in micro sleeps. That's what dozing, which are unintended periods of light sleep, either in the form of lapse in concentration, blanky, starring and daydreaming, or even momentarily nodding off. Micro sleeps can task between last a few seconds to a minute. So in a minute, we are not alert even few seconds. That's what is called micro sleeps. That can all put under creating high fatigue or fatigue is very important. Unwanted perception of driver or occupant during drive. So how can you get rid of that? So ensure that you get 7-8 hours quality sleep the night before driving. So if you have to plan our long trip, then you should have a sound sleep the day night. That's important. You're traveling night time. You should have sufficient sleep in daytime, and then you have to start your journey. Aim to not travel more than 8 hours a day. Take 15 minutes break every 2 hours. Where possible, alternate driving with your colleagues or with non-driving tasks. So if we do not have a co-passenger knowing driving, stop compulsorily, take break and then relax, then start your journey again. So avoid driving whilst on medication that can cause drowsiness. So you are under medication, you have taken some tablets that can induce drowsiness, you may feel sleep. Though you had a sound sleep, but you are under medication, you may always try no get a sleep dosing any time. So please be aware of it and eat a well balanced meal, avoiding fatty foods, and they can cause drowsiness. So as far as possible, take light foods and juices only during the drive. Don't take any heavy food or oily food. That is always not good, especially on a driving duration. Heat can increase feeling of fatigue. Therefore, fresh, cool air and music act as a short-term strategy of improving alertness. So your air conditioning system in your vehicle is good and you have a light music and then you go, that's very good. Music can act as short-term strategies for improving alertness. And then you have another aspect called vibration. So vibrations from the mechanics of moving vehicle can be transferred to your body through the seat and steering wheel. So that's what is the contact point from your foot floor and then your seat, your back, and then your steering contact points. All are the points through which you get your vibration of the vehicle getting into the driver. The operation of heavy machinery or heavy vehicles can cause a high level of vibration. So this getting vibration is also an important unwanted perception for occupant drivers. And such cases, the vehicle ergonomics to account that. So how can we avoid that kind of vibration risk? So vibration forces can be decreased with thick foam car seats, which can absorb some vibration as it passes through. So you can't avoid the transfer of energy to the seat, then work at the seat and its foam. And if the seat foam is firm and thick, then it can absorb some energy and that can reduce the amplitude of vibration. If possible, it is important to alternate a driving task with non-driving task to reduce the vibration exposure. Maintain a neutral spinal. Your spine is better able to absorb shock when the lumbar curve is being maintained in a neutral position. So what are these lumbar curve? All that go into vehicle anthropometry aspects. Right, and ensure the tire and suspension system are maintained. So your tires are periodically replaced. It's in good condition, and your suspension system is working properly. If your vehicle is with an active suspension system, or those electronic items are appropriately working or not, all inspection, maintenance of your vehicle is very important. Then sun exposure. So most side car windows can only block out approximately 37% of harmful UV rays. The most vulnerable areas whilst driving include the eyes, face, neck, arms, and hands, particularly on the right side of your body. This results in more pigmentation and sun damage on the right hand side of the body, increasing the risk of skin cancer. There can also be a problem of exposure of sunlight when you drive long duration. It is optimal. How do we reduce it? It's optimal to use UV blocking protective film on all windows to minimize the exposure. There are films that can be pasted on the glasses of your door windows that can protect the UV ray exposure. Wear sun protective clothing such as hat or long sleeves. So your hand also, if you wear full sleeve shirts and go, then it will protect. Then sunglasses are essential to prevent glare and reflection of UV rays. Sunscreens is SPF 30 plus. Apply 20 minutes before exposure and reapply every 2 hours. Then lip balms. So there are some cosmetics items are available that can also be applied on it. You could see our cricketers playing on hot sun. So they do apply such kind of creams so that their skins won't get damaged, right? Then importantly, the placement of vehicle controls, that's very important. So that no, ergonomics means it's not only confining with dimensions, anthropometry, also the movement of driver to reach out to all vehicle control panels. So in that aspects, vehicle control constitute an essential part of ergonomics, you could say. From cars with push button ignition, like many Toyota models, notably the Paris to power seats, automatic headlights, automatic climatic control, and electronic parking brakes. The latest in ergonomics innovation is often characterized by automation and ease of use. These features are notably easier for disabled drivers to use and allow many drivers to simply set a goal such as desired temperature of 70 degrees Fahrenheit or 20 degrees Celsius it is, and the car does the rest. So if you set this and then it is taken care. So ergonomics on active safety system, you've seen other electronic advancement in your vehicle that you've seen, all are also given important. So the vehicle control also constitute in ergonomic aspects. One or more intriguing trends in ergonomic design is the attention now paid to older drivers. All types of cars, including sports cars, are now being designed to have controls with a larger extent and better lighting to maximize readability, particularly for older or functionally disabled drivers. Even doors handles are being made to allow a better grip for people with conditions like arthritis. So this are all appearing maybe simple. So you can see that when you have to get in your vehicle and get out of your vehicle, something called design called ingress. So ingress something we will look at in today's class later. And the elderly people to get into the vehicle and getting out of the vehicle is not easy that we think. So when they have to get in and get out comfortably without any strain in their body, there should be an appropriate aids. That's what these handles that are presently available and to get in. The sport utility vehicle, you see, you have a platform also to get in and the vehicle. So how this all are taken care, we will look at in subsequent lecture. And placement of vehicle control. Again, if we continue to design control suitable for older or even for pregnant drivers, some auto engineers put shorts that limit their mobility and range of vision, or that come with a large belly, mimicking pregnancy, and so on. So elaborate body suits won't always do. So engineers do often turn to virtual reality and computer modeling. So the design aspects to do the every movement of expected driver movement, or the vision aspects, or the leg room, or their comfort posture for prolonged time. They do analysis in a CAD modeling, in a computer modeling. Then they try to improve upon on the vehicle design. This flexibility means that an engineer can easily test how a certain control configuration might be used by a 6 feet 200 pounds man, or 5 feet 120 pound man, and everyone in between. So that means distribution should be normal distribution. So it has to accommodate from ranging from 6 foot to 5 foot with the different gender and so on, right? So the program also allows for testing for people with disabilities, unusual body types, and special needs. So vehicle ergonomic design aspects are going many of simulation studies like that. With a few features, however, come from new challenges. Distracted driving is a major concern leading many US states. So this all information I have taken it from US based vehicle. That's why it comes to pass laws regulating drivers' cell phone use. At the same time, more cars are coming equipped with the integrated hand-free phone system. So you could see that you don't require to use your mobile phone. You have a steering system enabled with an electronic system. You have switches there. So the moment you get a call, it can be connected through Bluetooth, and then you are able to talk without handling the mobile phone. That kind of system is available now in vehicle, often incorporating Bluetooth. That's what. But the challenge then arises of how to make this system accessible and easy to use without distracting drivers and requiring them to take their eyes off the road. There's some speculation that future cars will need to rely more on audio voice control, feature that exist to a limited extent in some vehicles. That means like you have now Google search, you don't require to type, you can just say vehicle safety, then immediately the page opens. So anything that you want, you have an assist of making your voice, don't require to text. So such kind of commanding scenario is going to be there in our future autonomous vehicle also, that you say it does listen to you, it works. So such kind of aspects also that go in ergonomics. Then looking in specific, looking at this case of a vehicle, the placement of vehicle controls here, you can see. So there are 5 aspects here highlighted, 1, 2, 3, 4, and 5. So what are those? It's digital meters. So your digital meters should be here. So it's just to see, you could see the digital meter here. Your steering has got like this wheel, and then this semicircular portion is empty, because it would give you in the operating time complete vision to this display. So digital meters would be seen. So discrete digital meters maximize forward visibility and help create a sense of uncluttered spaciousness. So that is what is this aspect. And triangle motif steering wheel. So the triangle motif steering wheel helps harmonize exterior and interior design for a feeling of unity throughout. So that's what is this. You have this kind of design. And then centrally positioned audio panel. So you have your audio panel centrally positioned here. So and then textured dashboard and console. So textured dashboard and console. See, you could see this is not very polished. So it is very attractive. That's what is an interior aesthetic that going in. And then sporty 2-ton Physica. So that is here. So that is that your air conditioning system. The sporty 2-ton Physica adds a touch of pizzazz to the Linux interior. So this is all some of the control panel placement to improvise the workspace inside. And it's a classical example that Glastonbury Police Department, the police car of the future. So they are able to have nice environment, driving environment. See, they are able to look at this computer display, keyboard, and sophisticated sitting posture, and so on. So this all also resulted from an ergonomic analysis that go into vehicle design. So what is now getting into detail, what is this anthropometry? So you have to understand anthropometry is the dimension measures. So there are importantly 2 points called H point and R point. We will see in next lecture in more detail what are various references that go into ergonomic aspects that we consider. I just have highlighted these two in this. So what is H point is called a hip point. What is R point is called a seating reference point. So which it appears obviously the same point, but we have to look at when H point we have to utter, when R point we have to say that is seating reference point. So H point is theoretical relative location of an occupant hip, specifically the pivot point between the torso and upper leg portion of the body, either relative to the floor or floor of the vehicle or relative to the height above the pavement level. So the height, this will be located either from floor or from the pavement, road pavement. This is located here. So technically the measurement uses the hip joint of 50th percentile male occupant. So we are anyhow going to study more in human dummies, and there are dummies 50th percentile male occupant dummy would reflect most of the male driver human resemblance. So that is a popular dummy. So weaved laterally. So when this dummy weaved like that, this is what is called H point, where it is intersection of upper leg line and your back line meeting at hip, right? That is at the torso and upper leg intersection point is what is H point. Then seating reference point is theoretical hip point used by manufacturer when designing a vehicle, and more specifically describes the relative location of seated dummy hip point. Dummy hip point. When the seat is set in the rearmost or lowermost seating position. So this is how the two important reference points. So like that you have reference point for this foot rest contact, and then there is a ball reference point, and you have many of reference points that we will see in the next lecture. And this is what is again an anthropometry for go in occupant packaging. So this slide appears very complex, very much dimensional, informative, and so on. So that we will see very detailed. So what does that you understand here is it is going to have a wider range of driver posture seat design, whether it is of male to female. And accordingly, you see that H point of female is different, H point of male is different. So this distance or this variation in H point is subjective. It depends upon the driver, whether male driver, female driver, or fatty driver, or thin driver. There are many aspects that go in. So this would be varying. So that is so how the tolerances that go into accounting the posture design of your seat, and the resting position of your foot on the pedals, and the holding position of steering, and your back seat orientation, your neck rest restraint, your vision space that is through your windscreen. So you'll be able to cover the maximum vehicle front vision. So that would be different for a male driver as well as different from female driver, because of classification or the general gender differences all are there. So like there are many aspects that go into. So when you put the seat, it is again a class of vehicle, whether it's in a sedan class vehicle, sporty vehicle, or trucks that you go. So these all various angular tolerances are there. So like that, if you look at this anthropometry is all about placing the dummy so that the seating position for the dummy is adjustable, and we would ensure all the time comfort, whatever that we are looking at, the muscular disorders can be prevented. All such things to take care. This kind of measures are important. So we will see them in detail in the next lecture. I just have put this slide, though it's difficult to read. Later on you can zoom it and look at it once I upload this notes and the details, right? So you should this is appearing complex, but you have to systematically look at them, and then you will understand that. So it requires kind of patience, going scanning through carefully the details. So you see that here this black color outline is what is this is windshield, and what is that is the space available inside the vehicle. So it is the space available inside the vehicle, and it's space management for seating the driver, other occupant comfortably to meet the safe drive environment, is what is all go about called an ergonomic design, right? So we'll get those details in the next lecture. And also you see the anthropometry, like no, it is the tolerance of movement of your hands and legs. So that is again particularly given here when you're seated inside, your leg movement and your hand movement all important. So your leg here, lateral swing is shown here. So I should be able to move my leg, right leg as well as left leg on wider range of angle, so that I could accommodate, I could operate with a single leg also all the three aspects of pedal, accelerator, brake, and my clutch. So left leg is always on clutch, and the right leg should be on your brake, either on brake or on accelerometer. So this comfortably you have to play around with this important input for your vehicle without any fatigue or cramps in your leg. Seating position, that is very important. So here this all ranges numbers all are to account the ranges, because you can't have one anthropometry dimension and then design a vehicle. It has to accommodate any user. Any user can be an young chap to an elderly person, healthy human, man, women. So there are many aspects that go in everything to be accounted, and for that all what is important is the dimensions. So the occupant dimensions and vehicle dimensions with an appropriate referencing is all are the basics or fundamentals of vehicle ergonomic design. Again, it is in detail your legroom aspect and your dimension of foot. You see, it's different from male to female, and the requirement is different. All that go right. So with this all looking at, again, you could see here whether it is what you have seen here is for comfort sedan class, you could say. What you are seeing here is maybe for a truck or bus driver. So there you see the hip point is very much higher than that of the earlier vehicle, and their angle between upper leg and the lower leg, this angle, that's knee angle, is different than the other one. And the leg room here is not longer horizontally, but you have your vehicle space here goes from the touch point is go more in this case. So it is according to the vehicle that you drive. So you have a vehicle classified. So you see the seat that is there for a bus driver is not the same seat for the car driver, right? So like this all we have to understand. And then human models, when you talk on this, we'll see again the human model as a separate module, seventh module. But to brief to the context of ergonomics, just let us look at this. The crash dummies are full-scale anthropometric test device. That's why it's called anthropometric test device. Means the dummies are made to resemble a human, average human. So the dummies you place could accommodate the range of human types that simulate the dimensions, weight, proportions, and articulation of the human body. The following requirements for human models. What are those? The geometry, dimension, mass distribution, center of gravity, inertia, joint stiffness, degree of freedoms, all are important. That should be same as that of normal human that you consider healthy human. And then biofidelity. So measure for quality of reproduction of physical human characteristics. So there are standards for human dummy development, that is going to that ISO 9790. And robust construction, that is reliability. And then reproducibility, repeatability called. Then possibility of calibration. So you have to calibrate your dummies always before they are employed during test. Whether the test is to see the severity, to measure during crash test or on the sled test or on the whiplash test, anything. The dummy is a dummy to resemble a human subject, right? And handling. And then protection criteria applicable. Here, these all are important requirements of human models. Then anthropometry. What is anthropometry? Describes, I was keep on telling it, describes the geometric dimensions and proportions of a human being. So anthropometry, when you say, it is the geometric dimensions and proportions of human being, right? So anthropomorph, ATD, or Anthrop test device called human adequate properties, that is called mobility, deformability, properties of inertia. So these all are, what does that go in, called anthropomorph. Then percentile, you see that always human dummy is given with percentage. The percentile indicates that part of population which is taken into account. The HILL 50% represent 50% part of population, right? So this is all something that the basics of a human model and its requirement. And human dummy terminology is very important because this is where you measure a severe crush pulse and to quantify severity. And these are the locations where the sensors are mounted and so on. So the following figure, this figure is a typical HIL 50% male dummy with the sensors. These sensors collects data such as velocity of impact, crushing force, bending, deformation, and decelerations. The human injuries are evaluated based on these inputs. So you have an appropriate sensors to measure the event of crash. The dummy tree starts at pelvis area. So this is that pelvis area, and defines that defined as child and master. The master part governs the behavior of child parts. One of the typical example of tree structure is given below. So you see pelvis, femur, tibia, and foot. So this is all from here. So let's look at now here. This is head centroid accelerometer. So you will have at the head, you have CG, head CG accelerometer placed. Neck force and neck force and moment sensor is placed here. Then sternum deformation sensor is on this ribs. And thorax CG location. Thorax CG location is our sensory respiratory system. CG location. Then pelvis accelerometer, CG accelerometer here. Then femur force sensor, knee slider here. Upper tibia sensor and lower tibia sensor. So these are all something an important location of accelerometers that are there in your human dummy. So far what we have seen in this class is just a briefing requirement of ergonomic design for an automotive systems in brief. So we just have got a glance of all, not in detail. So next lecture we'll meet at 2 o'clock today, and we will see more detailed ergonomic aspects that go in. That lecture would complete our module 4, and then we will be left with 3 modules. So module 5 is to talk on vehicle safety system, module 6 is to talk on injury mechanisms, and module 7 is to learn of these dummies in detail and their history. So with that note, let me stop this particular lecture. If you have any doubts, you can ask. Otherwise, we'll end the lecture and meet again at 2 o'clock. Do you have any doubts? If not, I'll stop lecturing.